the way that the robot is built is not like the human is built. So if the human shows how to do something, that's not always perfectly applicable for the robots, unless the robot is really biomimetic. But we don't have robots like this yet.
At IROS 2025, we had the honor to interview Professor Robert Katzschmann from ETH Zürich.
My name is Robert Katzschmann. I'm a professor at ETH Zürich in Switzerland. We work on the field of soft robotics, also on topics such as biohybrid robots and musculoskeletal robots. So we have the first paper is on a robotic hand that we developed, where we want to show that we can extremely expand the space of operation of a hand. In that work we also kind of explore tactile information of how you can use also other tactile sensor inputs to actually sense what we grasp. In the second work, that one is called Orca, we look into a robotic hand that is an open source, tendon-driven hand that can be reproduced very easily. So like that you can, for fairly low cost, have your own robotic hands. You can tweak it, you can change it, and you can basically hack it the way you want to. In the third work, we talk about the use of robotic hands using something called model predictive control, coupled with vision language models. So here you have the ability to basically tune a more sort of the traditional approach of using model predictive control in simulation, and then also apply it to an actual robot hand to do the flipping of objects, to do the control of throwing an object and grasping it. Doing a very fine manipulation where the contact is only stable in a very specific configuration, getting that mapping from the teleoperation to the robot is already challenging. But the even more challenging part is for the robot now to learn and train a machine learning model. In this case, we would call them a vision language action model, or we also call them imitation learning models, to train it in such a way that they could just by itself, given a certain prompt, just do it. Like you tell the humanoid robot, pick up this iPad and go, and then it comes and picks it up and it knows which way to do it. That's really the next big frontier. And we need to advance both on data collection, so collecting data that the robots can learn, and also on the robot hardware itself, like how we build these hands, how they are actuated, how they're designed. Those are both open areas of research. If we can combine those two methods so that we are not fully just stuck with, I would call this maybe a technical, the convex envelope of what we've learned. Every single thing the human needs to do this and needs to demonstrate it in some way, either through teleoperation, so the robot does it and teleoperate the robot, or the human does it themselves, and we need to learn how to transfer the observation of what the human does onto the robot. But that method right now is obviously still limited to the things that we show the robots. And that's where I see methods like reinforcement learning can allow us to step outside of this envelope and towards learning even more activities, or to become even better. Because the way that the robot is built is not like the human is built. So if the human shows how to do something, that's not always perfectly applicable for the robots, unless the robot is really biomimetic. Biomimetic meaning it really imitates all of the degrees of freedom of the human, but we don't have robots like this yet. So that is always this gap between what the human does to the robots, and we are very limited of how much data we can collect through teleoperation. Like even if you put down a whole army of teleoperators that would teleoperate robots, it would still take you a very long time to collect the amount of data that we have collected for large language models. We are looking for students with a background in the field of robotics, so they can come more from the hardware side of building robotic systems and interested in designing, working with new materials, building new kinds of muscles, and all the way to systems engineers that really know everything from making the robot to how to control it and apply machine learning to it. And we also look for people that are more on the machine learning side, that like to think about new foundational models, new vision language action models that can be used on these robotic systems.